வணக்கம் நண்பர்களே, மீண்டும் ஒரு வீடியோவில் சந்திப்பதில் மகிழ்ச்சி. ஸோ இன்றைக்கி வீடியோவில் ஒரு இம்பார்ட்டன்ட் டாபிக் தான் பார்க்க போகிறோம். தட் இஸ் தென் வேவ் பார்ட்டிக்கல் டியூலிட்டி, தட் இஸ் ஃபண்டமெண்டல் கான்செப்ட் இன் குவாண்டம் ஃபிசிக்ஸ். Wave particle duality. Okay. So then what is meant by then wave particle duality, which is then fundamental concept. Fundamental concept in quantum physics. Okay. In quantum physics. About then wave particle duality, that is every particle. Okay. Then every particle. So then every particle means then like electron, photon, proton, etc. Okay. Those particles behaves as both particles and waves. So that depending upon situation, then depends on situation or experimentally preferred, okay, or performed. So this is the how to learn about from the wave particle duality. So then wave particle duality that is fundamental concept in quantum physics. So in every particle, so then every particle means like then electron, photon and proton. So in every particle behaves as both particle and waves. So then depending upon the what the situation we have to depends, and what all the experiment we have to prefer, then based upon then particle and wave behaves. Okay. So this is the definition about then wave packet duality. So in wave packet duality we have to define in classical and quantum. There should be a controversy. Okay. Then classical quantum it should be opposite. Like here waves means anga particle means here behaves as a wave. Okay. Okay. So in classical, and in quantum. So in classical then light and matter. Here also then light we have to take electron. Here electron as matter. So in classical then light behaves as wave. Here then matter behaves as particle. Okay. Here there should be a controversy. Here light behaves as particle, that is photon. Here wave. So this is the difference how to learn about from wave packet. So in classical then light behaves as a wave, then matter behaves as a particle. In quantum that should be a controversy for classical, then light behaves as a particle, that is photon, then electron then behaves as wave. So in electron in classical then light behaves as a wave. It is proved by interference and diffraction. Interference and diffraction. Okay. Then we have to prove then light behaves as a wave through then interference and diffraction. Here it is proved by then thinning solid masses. Okay. Here then light behaves as a particle, photon in quantum mechanics. It is proved by photoelectric effect. So these are all the important. Sometimes 1 mark கேட்கலாம். In that then electron that is matter behaves as a wave, then electron diffraction pattern, electron diffraction pattern. Okay, so definitely the most important we have to know about that, how light and matter behaves in classical and quantums. Okay, so then what is meant by here? Then wave particle duality means it should be then fundamental concept. In that then every particle like electron, photon and proton behaves as both waves and particles. Okay, so அந்த wave and particle வந்து classical எப்படி behave பண்ணும், then quantum எப்படி behave பண்ணும் நம்மளுக்கு தெரிஞ்சிட்டா then we have to easy for upcoming topics also. Okay, good. அப்போ then photoelectric effect by Einstein, in that photoelectric effect which one is? Okay, so அப்போ photoelectric effect, photoelectric effect, that should be Einstein. அப்போ photoelectric effectல இருந்து என்ன ப்ரூஃப் பண்ணுறாங்க? then light behaves as particle, that is photon. அப்போ here which type of duality we have to get? particle nature of light, so most important. Then second one, from Compton effect, from Compton effect what is proved that then X-ray scatter like particles with momentum, that is the important. So Compton effect knowledge, that should be involve momentum transfer. But in these cases then particle nature of light, so these are the most important. So then particle nature of light, photoelectric effect, then particle nature of light, then Compton effect. Okay, the next one, then Davisson-Germer experiment. So what we can prove to that? That should be then electron shows diffraction pattern, electron shows diffraction pattern. அப்போ in these cases wave nature of matter, so here this one is important. So then wave nature of matter from which one? Experiment, then Davisson-Germer experiment. Similarly then double slit experiment, then electron and photon produce interference pattern. So in this cases then wave nature of particles. So these are all the important. So from these cases then de Broglie so then de Broglie hypothesis. அப்போ de Broglie என்ன சொல்றாருன்னா, that is every moving particle is associated wavelength is given by then lambda is equal to h by p. So we know that what is meant by h is the Planck's constant, that is 6.626 into 10 power minus 34 joules second. Then p is the momentum, that is p is equal to mv. Okay, so this is the from these cases, then matter wave exists for all moving particle. So from this de Broglie hypothesis, what is this? What is we have to conclude from that? Then matter wave exists for all moving particle. Okay, so this is the concept we have to discuss in that wave particle duality. Okay, so next classes we have to discuss the important formulas and a problem related to this topics. Okay, so அப்போ ப்ராப்ளம் எப்படி கேட்பாங்க? ஸோ ஹியர் இன் திஸ் ஃபார்முலா, இந்த ஃபார்முலா வந்து நம்ம நிறைய விதமாக வந்து நம்ம எழுதலாம். ஸோ அதை வந்து நம்ம நெக்ஸ்ட் கிளாஸஸ் பார்க்கலாம். ஸோ ஹியர் தென் ஹெச் இஸ் ஏ கான்ஸ்டன்ட். அப்போது ஹெச் வந்து இட் ஷுட் பி ஏ கான்ஸ்டன்ட், அது மாற்ற முடியாது. அப்போ மொமெண்டம் கேட்கலாம், தென் வேவ் லென்த் சேஞ்ச் பண்ணி கொஷின் வரலாம். ஸோ அந்த ஓரியன்டான ப்ராப்ளம் நெக்ஸ்ட் கிளாஸஸில் பார்க்கலாம். ஓகே, ஸோ ஐ ஹோப் திஸ் வீடியோ இஸ் யூஸ்ஃபுல். Then we meet in that next video. Thank you.